Welcome back. Today we're going to be looking at Lesson 1-3 notes, segments, congruent segments, and segment addition. Unlike a line segment can be measured because it has two endpoints. And that makes sense because a line extends forever in both directions. You cannot measure a line. But with a line segment, you can figure out the length of one from one point to another. And you can use something handy like a ruler to do so. Let's take a moment to fill in the boxes here. We're going to review some of the things that we talked about in Lesson 1-1. Here's the meaning, and there's the notation. A segment with endpoints A and B. To write a segment, you need two endpoints and draw a bar above the 2 points. So in this case, I wrote A and B and drew a bar above them. This is called line segment AB. And if you wanted to, you can call this line segment BA. Next, a line that contains points A and B. You need 2 points to name a line. I will write A and B and draw a line above the 2 points. This is called line AB. Or you can call this line BA. The notations we're dealing with right now are in the language of geometry. We are talking about shapes. And we'll get into more details about what that means when we get into proofs. But for now, we will make a quick note on our paper that the notations are examples of using the language of geometry. The measure of segment AB is written as AB. If we know the length or measurement of a segment, we simply write AB without the bar. For example, suppose you have a segment with endpoints A and B. We call this segment AB. But if I were to give segment AB a measurement of, let's say, 3 centimeters, then the way we write this is AB without the bar equals 3 or 3 centimeters. Again, you do not write the bar above the 2 points, which in this case are A and B. This is using the language of algebra, which involves the equal sign. Now we will move on to the distance and midpoint between 2 points on a number line. To find the distance between 2 points, suppose you want to find the distance between A and B. Instead of counting through the line, there is a formula we can use to calculate distance. It's AB equals the absolute value of x sub 1 minus x sub 2, or the absolute value of x sub 2 minus x sub 1. Why do we need to put the absolute value around the two numbers? Well, we first need to look at what we're dealing with here. We are working with distance. Distance is always positive, never negative. We say 3 centimeters, not negative 3 centimeters. We are so used to saying the absolute value makes numbers positive, but how we should define absolute value is how far a number is away from 0. And once again, distance is always positive. We take the absolute value of a number once we find the difference between 2 points. Or in other words, after I subtract my two numbers, I then take the absolute value. Let's draw an arrow from the definition to the word distance to make this clear. And I apologize if you notice I spelled absolute wrong. There should be an E in the word absolute. And I'm going to put a space between the words absolute and value. So you have absolute value. Now the midpoint of a segment, if the coordinates of the endpoints of a segment are x sub 1 and x sub 2, then the coordinate of the midpoint of the segment is x sub 1 plus x sub 2 all over 2. It's basically taking the average of 2 points. Now I'm going to make a quick note here about the word midpoint. Whenever we see the word midpoint, we always need to know that it cuts a segment into 2 congruent parts. Suppose I give you a segment with endpoints x and z, where y is the middle point between those 2 points. What happens here is that since y is the midpoint, then logically the distance between x and y should be the same distance between y and z. Whenever I see 2 segments are congruent to each other, then I will draw tick marks to indicate congruency. One tick mark for xy and one tick mark for yz. So segment XY is congruent to segment YZ, which is the result of having a midpoint. It splits the segment into 2 congruent halves. Segment XY is congruent to segment YZ is me speaking in the language of geometry. If it still doesn't make sense, anytime you see the congruent symbol means you are in the language of geometry. Now, in the language of algebra, the measure of xy is equal to the measure of yz. I went from congruent symbol to equal sign. When I use the equal sign, I am speaking in the language of algebra where numbers, distance, lengths, etc. are involved. Now what I'm going to do is give these points numbers. Let x be -2 and z be 2. If y is the midpoint, what is the value of y? Since y is the middle point or standing in the middle, then it would make sense that y should be 0. Going from y to x should be the same distance as going from y to z. And I can use the midpoint on a number line formula to validate my answer. Again, the formula is x sub 1 plus x sub 2 all over 2. I would just need to plug in x sub 1 and x sub 2. So the setup should be -2 plus 2 all over 2, and -2 plus 2 is 0, and our denominator is 2, so 0 divided by 2, which is just 0. Now we're going to be looking at some examples. It says find the measure of BE. Let's write the measure of BE is equal to, I'm going to highlight where B and E are on the number line, use the distance on the number line formula, which is the absolute value of x sub 1 minus x sub 2, and then plug in and solve. So the measure of BE is equal to the absolute value of -6 minus 2. We are going to work inside the absolute value first. So what is -6 minus 2? -8. Then we're going to take the absolute value. I'm going to draw a picture of a number line with 2 points involving 0 and -8. If I walk from 0 to -8, my distance will be 8 units long. How far is -8 away from 0 in terms of distance? It would just be 8. Moving on, let's look at B. It says determine whether CA and ED are congruent. I'm going to erase the highlighting for BE so I can highlight CA. So to find the distance between C and A, I'm going to take the absolute value of -4 minus -7. And I always like to put parentheses around a negative number when it's after the minus sign so I don't confuse myself. So perform the necessary operations inside of the absolute value. -4 minus -7. I see that minus times a negative or negative times a negative. And yes, the minus sign is considered a negative sign. Whenever we see a negative times a negative, it turns into a positive. So we have the absolute value of -4 plus 7, which is the absolute value of 3. And how far is 3 away from 0? 3. The answer is 3, so therefore CA is equal to 3. Now we need to find the measure of ED. Let me go ahead and erase the highlighting so we can do so. E is 2, and D is -2, so the measure of ED is equal to the absolute value of 2 minus -2. A minus times a negative will be a positive, so now I have the absolute value of 4. Now how far is 4 away from 0? 4. Looking at CA and comparing it to ED, they have different measures, therefore not equal and not congruent. So I'm going to write, therefore, not congruent. Alright, C, determine the midpoint of segment DE. What I'm really happy about this problem is that I don't need to erase anything right now. I gotta find the midpoint of segment DE, and this is what I'm going to be using. X sub 1 plus x sub 2 all over 2, right? So this is my endpoint, and this is my endpoint. We're just basically looking at this picture here. So what's the midpoint of segment DE? Wait a minute, didn't we just do that earlier? Yeah, we did. So it's essentially just -2 plus 2 all over 2, which is just 0 over 2 equals 0, right? That's the midpoint of segment DE. All right, D, find the measure of DF and the midpoint of segment DF. I'm going to erase this and keep that.
F is over here. So to find DF, I got to find the distance between the two. So DF is equal to -2 minus 5. Don't forget the absolute value. And then you have the absolute value of -7. How far is -7 away from 0? You just say 7. And then to find the midpoint of segment DF, we just do -2 plus 5 all over 2. So -2 plus 5 is just 3. Divide by 2. And okay, well, we have 3 over 2. You can leave that as your answer if you want. Or if you want to divide those two numbers, that's fine. You can say 1.5. So the midpoint of segment DF is 3/2 or 1.5. Now over here, we're just going to go ahead and clarify some stuff. Between any 2 points on a line, there is an infinite amount of points. And that makes sense because, okay, suppose that you have N and B. How many points are there between those two endpoints? Well, we can't give an exact number, but we can safely say that there's an infinite amount of points. You have 1.1 or 1.2 or 1.21 and so on and so forth. And that's what I'm trying to get at when we're talking about infinite amount of points between 2 points on a line. Okay, in the figure, point N is between points A and B, which makes sense because, okay, here's A, here's B, and N is between those 2 points. However, point P is not because point P is not on that line whatsoever. Okay, so we can now go ahead and just transition to this postulate here. Super important that you know this. The segment addition postulate, which states that if A, B, and C are collinear, then point B is between A and C if and only if the measure of AB plus the measure of BC is equal to the measure of AC. Okay, so this is our segment, right? This whole segment is the measure of AC. If I break that segment into 2 parts, well, I have a part plus another part. And if you were to combine these 2 parts, well, what do you get? You get the whole thing. We got AC. So the segment addition postulate says that AN plus NB is equal to what? What's the whole thing here? AB, the measure of AB. All right, so I really want you to say part plus part equals whole. Part plus part equals a whole. Part plus part equals a whole. Let's look at the examples on the following page. So here's the next page. We're going to practice drawing and setting up algebra equations for segment addition, just so we have an idea. All right, B is between A and C. How do we draw that? Well, we're dealing with segments, right? So A and C, it implies that those 2 points are our endpoints. So here's A, here's C, and B is between those 2 points. So I can go ahead and put that over here. Does that make sense? B is between A and C, or if I wanted to, I can say A, C, and put B over here. It does not matter. I still satisfy the problem. All right, now let's take a look at B. M is between H and K. So H and K are our endpoints, and M has to be between those 2 points. So I'm going to go ahead and draw 2 examples. All right, So we can go ahead and say that over here, AB plus BC, right? So this is my part plus part. What's the whole thing? AC. And then over here, this is my part. That's my another part. What's the whole thing? HK. So HM is my part plus MK, which is my other part. The whole thing is HK. HM plus MK equals HK. Now C is a little different. It says that Y is the midpoint. Y is the midpoint. And what does a midpoint do? It splits the segment into two congruent parts. So I'm going to go ahead and draw my segment with endpoints X and Z. And we know that Y is the midpoint. So it can't be here and it can't be there. It has to be in the middle. So there's Y. So since Y is the midpoint, what's the result of that? Well, again, it splits the segment. It splits the segment into two congruent parts. We can say that segment XY is congruent to segment YZ, or the measure of XY is equal to YZ. All right, so I'm going to go ahead and draw those tick marks to indicate congruency and say that segment XY is congruent to segment YZ. And because I use that congruent symbol there, this is in the language of geometry. And then over here, I'm going to say the measure of XY is equal to YZ because I used an equal sign. That's the language of algebra. All right, so this could be 3, and this could be 3, so 3 equals 3.
If I'm referring to this.
Now we're going to go ahead and use segment addition to solve following problems. Find the measurements of the following segments. Figures are not drawn to scale. Okay, so it says find the measurements of the following segments. So it says FE. I got to find the measurement of FE. What is it equal to? We are in the territory of algebra, okay? So, well, let's figure out what FE is. So FE is this segment here. I can see my part. I can see my other part here. And remember, part plus part equals whole. So one of the parts is 1.2 centimeters plus my other part, which is 1.9 centimeters. And that's going to equal to 3.1 centimeters. All right, so it's ED plus DF. So this was ED plus DF, which equals EF. All right, now we're going to go ahead and move on to 2. We're going to find the measure of AC. All right, so this is AC. That's the measure of AC. And the measure of AC, what actually is the whole thing? It's 2x plus 5, but if I break up AC, we have x and 2x. But same thing as before, y'all. It's part plus part equals whole. So one of the parts is the measure of AB plus the measure of BC, which is equal to the measure of AC. What I'm trying to figure out. All right, so AB is currently x plus BC, which is 2x. And then AC, that whole thing, is 2x plus 5. All right. So remember, if you have a dog, plus 2 dogs, how many dogs are there? 3 dogs. So if we have 1x plus 2x, how many x's are there? There are 3 x's, which is equal to 2x plus 5. And as you can see, we're doing algebra here. So solve for x. I'm going to go ahead and do this. I need to have x on one side and the number on the other side. So here's 3x and there's 2x. So I'm going to subtract both sides by 2x. And I get, well, 3x minus 2x is just x, equals 2x minus 2x cancel each other out. And I have 5 on the right-hand side. X is equal to 5. All right, I have x is equal to 5. Am I done? No, because remember the question here is saying that we're trying to find the measure of whatever we're trying to find the measure of. In this case, we're looking at the measure of AC. How long is AC, right? I only know that x is equal to 5, and we know that AC is 2x plus 5, right? So what do I have to do here? Well, I have to evaluate. I have to plug in. Since I found what x is equal to, all I gotta do is look at this expression here and replace x with 5, okay? So let's quickly highlight x is equal to 5, and there's our little x there. So to find the measure of AC, remember, you don't write with the segment bar, by the way. You just say measure of AC without the bar. AC is currently 2x plus 5. So I'm going to replace x with 5. So 2 parentheses 5 plus 5. And 2 times 5 is just 10 plus 5. 10 plus 5 is 15. That's the measure. That's how long AC is. So how long is AC? It's 15 units long, and we are dealing with the language of algebra. The measure, how long is that segment, okay? You're assigning that value, or you're trying to determine what the value that segment is, okay? All right, number 3. Find the value of x and rs if s is between r and t, where rs is 2x, st is 5x plus 4, and rt is 32.
And I'm going to use this opportunity to highlight this part. S is between R and T.
What is this trying to ask me to do? It's asking me to draw a segment. So our endpoints are R and T, and S is between those 2 points. All right, so we know that RS is 2x. So this is RS. And then ST is 5x plus 4. And we got to make note that RT, the whole segment, is 32. So we're going to apply the segment addition postulate, or in other words, part plus part is equal to a whole. I have 2x plus 5x plus 4 equals 32. I'm going to go ahead and combine the like terms here. So 2x plus 5x, that's 7x plus 4 equals 32. And I got to go ahead and get that 7x by itself. So I got to subtract both sides by 4 here. So I have 7x equals 32 minus 4 is 28. And then I'm going to divide both sides by 7. So x equals 4. And because it's saying that I need to find RS after I find x, I'm going to take that x equals 4 and I'm plug that in to what RS is. So RS is just 2x, and that's going to equal to 2 times 4, which is 8. And that's how long the measure of RS is. Number 4, find the value of x in AB if B is the midpoint, keyword, midpoint between A and C. All right, so here's A, here's C. B is the middle point. It's going to split this whole segment into 2 congruent halves. So draw a tick mark here and a tick mark there to indicate congruency. We know that the measure of AB is 9x minus 5. And the measure of BC is just 7x plus 3. All right, well, what do I do if we have a midpoint problem? If B is the midpoint between A and C, what do I do with these two expressions? Well, first of all, y'all, we know that segment AB is congruent to segment BC, and that's the language of geometry, right? We know that these two segments are congruent. We also know that AB is equal to BC, right? That's in the language of algebra. So what's AB? Well, AB is 9x minus 5, which is equal to BC, which is 7x plus 3. 7x plus 3. And then I'm going to go ahead and solve for x. So subtract both sides by 7x. I get 2x. 2x minus 5 equals 3. All right. And then I'm going to go ahead and move all of this over here. And I don't need this anymore. All right. So 2x minus 5 equals 3. I'm going to add both sides by 5 here. So I have 2x equals 8. And I'm going to divide both sides by 2 here. So x equals 4. All right, so we know that x is equal to 4, and I'm being asked to find what the measure of AB is. This is AB. So AB is currently 9x minus 5. So replace x with 4. So 9 times 4 minus 5. 9 times 4 is 36 minus 5. 36 minus 5 is 31. That's how long the measure of AB is. All right, so we are almost done with the notes for today. We're going to go ahead and refer to the picture to the right. If two figures have the same shape and size, they are congruent. And we talked about this in 1-1. If two segments have the same measure, then we say that these two segments are equal to each other. They are equal to each other. Now, those slashes on the diagram, or sometimes I will, or most of the time, I will say tick marks. So, tick marks. Those tick marks on the diagram indicate congruency. There is a symbol for congruent, and it is this symbol. When we use this symbol, we are talking about the language of geometry. All right? So therefore, we say that, okay, segment AB is congruent to segment CD. That's in the language of geometry. Or if I say AB equals CD, which is also true about these two segments, the measures are the same, they're both 1.7, then we are in the territory of algebra. All right? Now, try these. WX, what's WX? Well, I know for sure that we can see that WX and XY, they both have 2 tick marks. That means that those two segments are congruent to each other. But do we really know what WX is? No. So if we don't know what something is, What we do in mathematics is we just give it an unknown variable, and we just call it x most of the time, right? So wx is going to be x. And since these two segments are congruent to each other, if this is x, this has to be x as well. All right? Now, we're going to go ahead and apply part plus part equals whole here. So x plus x equals the whole thing, which is 6. So the whole thing is 6. X plus x, 1x plus 1x, it's 2x, equals 6. Divide both sides by 2, x equals 3. So if x is equal to 3 and x is equal to wx, the measure of wx equals 3. 3 what? 3 centimeters. And that's my answer. Number 5, determine whether the pair of segments is congruent. We have segment MN and segment RQ. Are these two segments congruent to each other? We know that the measure of MN is 4x. And the measure of RQ is also 4x. So I can say that MN equals RQ. That's in the language of algebra. But that's not what I'm trying to prove here. Because I know that MN is equal to RQ, then it implies that segment MN is congruent to segment RQ. And there you go, I just proved it.